start streaming. We're live from downtown Mabea. Get rid of this because I now know this here. So let's get rid of that one, do a new one. This should be good. I think now that I've played monk music for a day, we should have this every class. It just elevates everything. Okay, different type of problem. This time, grab your partner, do a do-si-do, and then go to the board and calculate the solubility for
I'm not do-si-doing.
Well, if you must not, that's fine. No, you're with Elena. Oh my God, Elena's not here. So join another group. Hold it. Did this not update?
No, that's your old one.
No, I made a new one, but I think it didn't update from my phone to here. Is anybody else missing a partner? Basically, yeah. When we, it's like the difference.
Is it just that we don't divide multiply?
Because KSP always has a solid on the left, it's always multiplied, never divided.
Oh, yeah. So every time there's a KSP, it's always multiplied.
Yeah.
If it's KSP,
Then the products over reactants, it could be either way. It depends on the solids and the liquids. Yeah. But yeah, it's like KSP is a cat, KP is a mammal. They're all different types.
No.
Do you agree?
yeah.
I didn't hear you with someone. Okay. Yeah. Sorry. Oh yeah, that we did one last day. Yeah. But not just computers. Remember that number there is the KSP, not the solubility. I'm not asking you to calculate the solubility.
Yeah, you are. Calculate solubility.
I'm asking you to calculate solubility. The way you put it in there, you were saying you had solubility.
Yeah, 2+.
KSP is not a concentration. Okay, Evan, do you have someone you're working with, or are you doing it on your own? Okay, fair enough. Oh yeah, I accidentally worked on that nice here. It's weird. Okay, now it should be good. When in doubt, I can't emphasize enough. When in doubt, write out the equation and figure out what solubility would do. Who said what? There's tons of markers here. Just remember, and yeah, those are new, so. And put the caps on when you finally.
That's right.
Nope.
What?
Nope.
How do you do it?
You're close. Write out the equation and figure out what x would do.
What X or what?
What x would do. You have assumed it's cubed, which may be from memory or may be a very good going through. However, x is not x in all of them. That's the
Makes no sense. B is wrong.
It is wrong. It's close, but it is the classic mistake.
You said this last time, and then we asked you if you could cube it. You said yes, cube it.
Yeah, you should do that.
Well, then how are we?
Well, first of all, you take a square. You can't take a partial square root. You have to take a cube root. Like you can't. If you do the same thing on both sides, you can't just cube root one. You have to cube root. However, it's not all x.
Wait, Mr. Newfeller, we're supposed to do the OH? I mean, square the OH.
What?
We're supposed to square the OH?
It's KSP. You should. Yeah, that part's not. That part's right.
Oh, I'm confused.
Well, I'm waiting for someone to get it. I don't want to give it away. I want someone to discover it, and I want it to be memorable. Has everybody written out the chemical equation? Yeah, yours is wrong.
Wait, no. Do I get the X value and plug it in the square, or do I do it by hand?
You're on a better track now.
Wait, no, how is that wrong?
Do you square when you do stoichiometry?
Do I put it back into here?
Yeah,
Or do you square? Okay.
but I have to see what you're doing to fully say yes.
Wait, B.
If I plug in the values.
I think everyone might be in the same section. So if this is x, what is the value of mg plus 2?
Do you square 2.2?
If the solubility is x, how much mg plus 2 will you get? It's not a trick question. No. If the solubility, this is the K.
Oh, 1.2.
No, that is the KSP. That is not a solubility. The solubility is x.
We get the same answer.
Then X.
X squared.
X.
I don't know what you're doing. That would be x. What would this be?
X squared.
Not. You've never done x squared with this is stoichiometry. What would this be?
2X.
2x.
And then we plug it in.
And then if you plug it in,
That's what I did.
do you get x cubed? No.
Oh.
No. You haven't accounted for that.
Are we supposed to do X? So it would be X times 2X squared. Yeah.
Yeah. And we did do that last day, but the reason I have these two problems is because this always needs review.
So was it 4?
Wait, times 2x squared?
Yeah, because M, no, is it like OH is 2X?
Wait, so the felt, is it like this?
Hold it. I don't. Why do you have numbers there?
Yeah.
Because I skipped the X part.
But x is what you're solving for.
Yeah. Oh, I done that one. Because I got a penalty and
I don't know because I won't know until I calculate it because I don't. Oh, if x is 2.24, then that might work, yeah. But that one on the right, is that a 4 there, not a 9?
Yeah, there's no.
Oh, okay, then that should be fine. Yeah,
So
yeah,
that's right?
yeah. But you don't use those numbers ever because what you do is you take that x, right, and you put it in here. You take that x and you put it in there.
So we have.
And so you get x times, what's 2x squared? 4x squared.
And then times another X.
Times another x, you get 4x cubed is equal to the KSP, 1.2 times 10 to the minus 11. And now divide by 4 and take the cubed root.
No, you did not teach us this.
Oh, it's
It's math. It's algebra.
We did it last day. That's what we did last day. We did it. It was the last problem we did. People may have been tired. But it was the last problem we did.
Dude, I'm basically except I didn't English here.
Oh, I get it.
Yeah, don't do that. Please don't do that. Please don't put the 2 in there. No, don't.
what?
Take the 2 out.
Wait.
Don't make me run screaming over there in a panic. Take the 2 out.
2x squared equal 4x squared.
Oh, does it have to be outside?
No, it's already.
So I just have to change everything to X? What?
One at a time. Okay, for you, the concentration of hydroxide is 2x, right? So this isn't times 2, it would be 2 times. So you don't put it in there, right? That 2 is already reflected
So
up
you
here.
have to change it to X and then add the 2.
Yeah, and then you put the 2x because the amount B, to answer yours, the concentration of hydroxide is 2x, right? So when you square it, you have to use both. I will. It does take algebra,
Really?
but I've checked. It is grade 10-ish algebra.
I failed grade 10 math.
Seriously?
Yes. Is that right?
But now you're good.
No.
Oh, I didn't ask you that demonstration. I just asked you for the, but, I just asked you for what X was. But yeah, I actually don't know the answer, I'm just waiting to see what everybody gets, but it looks like everybody has it.
I know, but like, try it again.
Okay, what do we get as an answer? 1.4 times 10 to the minus 4
And then 2 sides.
is the solubility. Yes. I think, yeah. Now, I didn't ask you for the concentration, I just asked you for the solubility, so once you got to X, you were good. But yes, if I asked you for the concentration, those are both correct. Well done. Once you're done, you can have a seat as long as you understand it. If you want me to call over, because this is an error I know that happens. At least it's not a donut that you were late for. Yep. I have these two right away, but I feel like if I made up a problem that was more complex than anything you'll ever see, it would help identify some of the confusion. Yeah, thank you. By sheer applause from Matt, this is what's called an AB problem. AB problems are always take the square root. This is an AB2 problem because when it comes out and you get 2x, that's always going to be squared, that's going to become 4. So always write the equation and go through with what the solubility would be, plug it in, do the math, and it'll work out. We don't do like an A2B3 problem, but algebraically, that should be fine. So if I gave you aluminum carbonate. I'm going to just make up this number. Let's make it something easy. 3.0 times 10 to the minus 6. Pick any partner you like and just work this out from first principles like that AB problem. You'll never get a question like this, but if you can do it, you will be fine in all the questions. Huh? Yeah, I want to see. I want to see. You have to what? I do make you walk a lot, but this really helps me see how people are doing. Also, there's literally a ton of research. More blood goes to this. Oh yes, calculate solubility. people are writing just for free.
Yeah, okay, step by
Ooh. Oh, I'm not gonna tell you you're right until you give me the final one. All the way to the end.
No, but this is 2x.
I'm gonna wait till you get to the destination.
Yeah, but then it goes back.
Oh, I understand. Oh, wait, no.
I'll check it inlet.
Yes, but don't write the 2 in there.
But this is right?
But that's right. Yes, and then but multiply it through.
Oh, yeah.
Yeah.
I'm behind.
Mine did. And then it just didn't.
Okay. I said it's negative 2, dog. Oh, is it? There you go.
Hold it. Your X disappeared. That's just weird. There you go. Algebra.
Oh no, that's just.
There's your KSP equation doesn't have any exponents.
Yeah.
This is 2 and
I don't know,
3x,
makes
right?
sense.
Oh, is this
It's like 2x and then this is like 3x.
Yeah, you need to write the KSP equation with the exponents now, and you'll be off to the races. Yeah, your KSP equation with exponents. If you were to write the KQ for this, like the KQ for that, which is the KSP, is equal to what times what? This is a solid. So those are aqueous. What would you write? Forget X. This is just old KQ. What would you write?
Oh, it'd be AL squared.
AL plus 3 squared.
That's what I was doing, and then I was told I was wrong.
New.
CO3 minus 2
Cubed.
cubed. And now put in your X's.
Is this right?
Nope. What's your new fella?
We have the same ones. Looks good. You got 27 inch. Yep.
This
Yeah.
Is this right?
Yeah. Looks like yeah.
What's your new fella?
And that is like the hardest version of that problem. And we don't even get
How
it
is that
to
easier than the one from before?
Pardon?
I was just gonna ask a very random question. Did you just have that outfit, or did you buy it just specifically for this?
Well,
You had it last year too.
sometimes you need extra. Oh no. I think ages ago I said I was going to do this, and Mrs. Widdenmeyer donated it from the school prop outfit area,
There you go.
with a promise that if there was ever email sent out saying we're missing a monk outfit, I have to give it back.
How long's it been?
2 decades.
Yeah, I don't think they do that.
What's 4 times 7? 48.
28.
So what is this, 108?
Let me see.
Is it 104 times 27 is 108?
Yeah.
Yeah, 246. Yeah, it is. That's the fifth.
Mine's like oh yeah. Oh, okay, okay. I was gonna say, like, that's
Well, you have that. So, if this, because we don't know the solubility, but whatever the solubility here, X is, stoichiometry, the amount of aluminum will be 2X. Because stoichiometry is balance. And the amount of this will be 3X. So, right? The cube, because the KSP is the concentration.
Did you try to turn on any faucets by chance?
But we put them in, and then we square and cube them, and then we solve this.
Showers won't turn on. Sinks won't turn on.
Where did the cat go, brother?
Okay, please find the
It
cat.
does suck.
Because I get in trouble when I use up too many too fast.
Come on, man.
Too fast, too furious.
Is that what they call you?
Yes. All the time.
So gross.
That's my nickname, and I'm going to try and enforce that.
Oh, I see a cow. Might not be the one, but.
Okay,
That might be the one.
is that good? So the actual problem I would have given you next, we have an AB and an AB2 problem. Treat it now that you can do the more complicated version with the contempt it deserves. Go through, quickly give me the KSPs of both of those. Pick your partner again.
Are we doing sitting down?
Yeah, I'm not kidding.
Do it sitting down, I will ask someone for the answer.
Okay.
These two problems, both of them. I'm Groot.
And then
You got the first one?
I think so. I don't know if I have the whole
What do you got?
process. Take the square root, right? So, no.
you don't have the square root? Or do you?
Pretty sure it is.
Oh, I don't tell you how. You said you got it. You tell me. Life on the line.
Okay, I got 1 point, can we do 0.5 times 10 to the negative 5.
Yeah, and well, you know you take the square root.
Oh, well, it's just half.
And yeah, that's going to be half that. So you can just look at it and go, oh yeah, that makes sense. Because God, sometimes I wish we still had chalkboards. I could write so much faster.
Does that have anything to do with the churches?
Pardon?
Yeah, like, did the churches matter?
Yes.
Okay.
BA plus 1 would be a different thing than BA plus 2, but there is no BA plus 1.
But I know that sulfate's -2. If I write -1, that would be wrong.
Yeah, but it doesn't actually matter for the answer to the question.
Well, I don't know, Evelyn. I said, I don't know, Evelyn. It doesn't matter as long as I get the E part of your name right?
I understand it's the, like,
You'll respond.
yeah. Okay, but, like, you're not gonna get, like, it's, if you miss that step, it's not gonna give you the wrong answer.
No, in this case, you'll get away with it.
Okay.
But it's a bit like every chemist will mock you. Yeah. It looks very bad. Okay, we have an answer for the first one. A reminder, KSP doesn't have units, but solubility does, so they'll always be moles per liter. Anybody have an answer for the second one? How many people have an answer for the second one? Just one? I'll wait a little longer then. Thank you. This is really loud monkey music now.
Or it's
Ooh, I now have
divided by
requests.
2 and then you take the square root.
That's why.
It's one of the two.
It's not to the power of 3 because CO3 is 1 It's not like
Can we have a question again?
Oh, sorry. Yeah. I keep forgetting that when I used to do this and I'd have 2 separate screens, and then I forget that like everything I do, you can see.
I got x equals 1.28
It was hilarious. Our old, the person that used to have Mr. Sullivan's job came into his class, told them, like, you got to settle down. Something big's happened in the school, because he was also Mr. Sullivan's job, and he was also teaching class. Please get to work on your assignments. I've got something really important to do. He sits down, he forgets his projectors on, and they see him checking rugby scores. There were some important games the night before.
What was he checking?
Rugby scores.
Did you like him or Mr. Sullivan more?
I like them both equally. Oh, hold it. I'm being recorded. I like Mr. Sullivan the most.
I'm Sullivan.
I feel like you should get like a red light put on when you're streaming.
There is a red line on it.
Well, that's on all the time just because it's plugged in. I'm sure it's fine.
You seem to forget too.
I do. Well, they did an experiment where they put cameras in a series of daycares that had like little children. And the whole point of the study was to record behavior and see if people change
I
their
did divide by 2,
behavior
so we'll find out.
based on whether a camera's present. They found out after a certain amount of time, people just go back to doing what they're doing. So they found incidences of people like not being very nice to the little children because they just kind of forget the camera's there. So once it goes on long enough, you just kind of forget. This is why one of the proposals
So you're not
that,
gonna be nice to us and forget.
well, like if I'm not, it'll be recorded, but I will have forgotten and then it will be recorded. One of the reasons for why they say, police should have cameras on themselves, because you do forget, and then that way you can have evidence, because it's hard to investigate the people in charge of investigating. That's a classic philosophical problem. Okay. Finish up. Someone volunteer. Finish off the equation for me.
Plus.
No volunteers. Preston, newest member. Finish off the equation for me. No, just the chemical equation right here. Plus CO3, charges on them, and how many? charges. Yep. Minus 2. And then how many of each? There you go. So we got the 2 there. What's the KSP equation? Let's go with Naomi. Naomi has left. I already gave her the point. I have to ask her when she comes back. Matt, what's the KSP equation?
The equation?
Yeah, just like concentration of times concentration of.
That's 8.5
No. Just do the generic equation. Like from this, what's the equation?
square bracket AG square bracket to the power 2
Yep.
square bracket CO3 square bracket. Oh, the charge.
Yep. Charge is minus 2.
Charge negative 2.
Okay. Naomi, finish it off. What do I put in there?
I'm so lost. I like it just left. Where am I?
Oh, had you finished this? So we've got the chemical equation, we've got the KSP equation. What do I substitute?
1.28 times 10.
But no. Next step here.
Oh. 8.5 times 10 to the negative 12 equals concentration 3x close times a new one, a new bracket, 2x close squared.
Yeah, why 3x?
Because of this here. I got the answer that we got, so.
If this, no external humming, if this is x, what's the concentration of Ag plus 1?
Oh wait, no, I did it wrong.
That's okay.
It's just x.
But as general to the class, what will this be?
What?
2x. And what will this be? X. So that is independent of anything there. So we would substitute those in as 2x squared and x. And so this is going to be one of those 4x cubed problems. Volunteer, what is the answer? 1.29 times 10 to the minus 4. Excellent. How much time do I want to go into quiz time? 1:45. Okay. Okay. Notey stuff. We're up. If you remember back when we did KQ trial, or Q, Q is KQ trial, or in this case, KSP trial. I think your book actually writes trial. I write Q just because it's shorter, and I don't confuse it with the actual KQ trial. But that is when you have numbers that could be their concentrations, and you want to calculate them to see if you're going to get a precipitate because the concentrations are too high. Remember the concentration, the KSP is a product of the concentration of ions at their maximum. So if you multiply it together and Q is, say, less than the KSP, we'll start at the beginning, will you get a precipitate? If it's less, you're not going to get precipitate. The ion concentrations are too little. If it's more, yeah. If it's equal, maybe a little bit. You're right on the cusp. So you are just at equilibrium.
Wait, what is Q equal? What is that?
KSP trial. That was supposed to be RIA. Okay, I find the Om one much more creepy than the monks.
Can I go back to monk music?
Yeah, I think so.
I forget what the monk is talking about.
So if you have numbers and you throw them into the equation and you get a number that's too big, that means your concentrations are too high. So it's going to have to shift left and you're going to get a precipitate. Nope, not that one.
Does the recording
Best
have
Georgian
the
chance.
ums in the background of
Probably. I mean, it's just all microphone. Yeah. Okay. So let's do a couple of those. Equal volumes of silver nitrate and sodium chloride are mixed. Will a precipitate form? Prove it with a KSP calculation. And
I don't get what Q is.
Q is like the KQ trials.
What is the KQ?
when you calculate the KSP, you have something at equilibrium, right? And so whenever you get something to KSP, we don't know if these are at equilibrium. So you calculate it, the same calculation, to see and compare. So it's a trial because you don't know if it's going to be equilibrium or not. So we want to call it something different so we don't get it confused, but it's the same calculation.
If they're equal, it is.
Yeah, if they're equal, it is at equilibrium. Nicholas, you can join any group you like. Nope. Did that not? Why is it doing that?
Select all.
Find your partner. Use those numbers, come up with the equation, do the calculation, compare to the KSP. Erase all previous work on the board. Let's get rid of that. When in doubt, write a chemical equation.
From this, will a precipitate? Oh, okay. I have a weak shin.
Matt and Evan, you don't look like your room. There's a window spot over there.
I'm unfortunately
Yeah,
You don't
pardon?
have to do it now.
Why do you mean you don't have to do anything? How do you know? Which one and how do you know?
And then,
How do you know?
wait, are we supposed to?
Well, that's a 0.1 molar solubility table. And one of these is less than 0.1 molar and is being diluted. So you're going to need the KSP to prove it.
Are we combining? Okay, yeah. Is this right though?
Yeah, it's a chemical equation. Yeah. Put in aqueouses and things. You should be good. You have to prove it with a, like on the last page, compare it to the KSP. You've got concentrations. You can calculate concentrations. Well, which one is our potential precipitate? Whoa, that is. No plus signs, and KSPs are for net ionic solubility tables. So a lot of this is an exercise in equation writing to begin with. Oh, there's more up there. There's so many more.
Oh, did I steal your solid?
If you are writing a KSP of the entire equation, a reminder, KSP is for net ionic solubility tables, not formula equations. No formula equations. What's your potential? You know what potential is? How'd you know that? Yeah, so you know that might be the solid, but given the concentrations, the solubility table is only on a certain concentration. But then that's the one you're going to examine. The other one's like sodium nitrate, it's the most soluble thing in the world. So now you need a net solubility equation, just like we've been doing all along. What do those look like? No, that's a formula equation. That is not a net ionic solubility.
Wait, do we then just like take that out?
Yeah, a net gets rid of all the
Things that we don't want.
the spectators. Yeah. There are things in there that should not be in there. You want a net solubility thing for solubility. You have the formula. Get rid of all the spectator ions. And put it the right way around. Ooh, we're on track over there. Somewhat on track anyway.
Do we substitute the K
Does that feel like a solubility equation? Do they divide very often?
Okay, I am right. So like, I give up.
Do we divide very often as a solubility equation? Have we divided this whole time? Is there a way that we constructed our formula so we would never have to?
Oh, the solid on that. Solid on that.
Where'd you get the numbers from?
It's supposed to be house spirit, not
Oh, close, except those aren't their concentrations. Equal volumes are mixed, so they were diluted. But you're on the right track. You're totally on the right track. Well, equal volumes. Equivalent, like. Oh, I'm not gonna. I gave you a hint. That's not it.
Wait, so you want the solid on the
Is your new belt?
Always for a solubility table.
What?
Ooh, nice.
What's Q?
Where'd you get 1.8 from? Nice, you looked that up. So you're gonna have to compare something to it, yeah.
What are we comparing? I don't know what Q is.
So Q is when you have values if you don't know it's at equilibrium. Do you know if it's equilibrium with these values?
No.
No. So calculate the KSP with those values, or whatever from those values. But don't call it KSP because you don't actually know what it is. Call it Q.
No, that's not both.
Can't do this on us.
Don't look at our, don't tell her. Okay, HGCL was already.
What is the KSP for silver chloride? 1.8 times 10 to the negative 10. Right. So you calculate KSP with that, right? But we just want to compare that number with this. So what we do is you go, okay, I don't want to call it KSP. I'm going to call it Q. Because it's a pretend KSP. What's the concentration of silver ions?
Oh, it's 0. Did I 0? 2.
It's close. Equal volumes are mixed. It's diluted. You took a liter of that, you mixed it with a liter of the other stuff. What's the new concentration?
Is this right?
Where'd you get 0.012? But that would be those numbers. You can't add them together. You want the concentration of silver separate.
It's smaller. I don't know.
Okay,
It's not really. I'm not big on it.
How did you guys just get no and nothing else?
we erased all our. It was like all of it.
Here, I'll be sitting with it. Like, I was gonna see it.
Oh wait, is it just you don't know, is this right? Wait, is it Q?
I don't know.
Do my hands just like
I don't even remember.
Eventually. Yeah.
Mr. Newfound.
Because it's going to be like the KSP. Over and 0.02.
No, I think I know.
Where, you used 0.02?
Well, no.
Ah, but it was diluted. Equal volumes were mixed. So you have to divide the concentrations by 2.
Mr. Newfeld, can you check this?
What'd you get?
So then it's 0.1 and 0.5.
0.5? I don't know the actual number values. Look up here. What was your concentration for chloride?
I think I remember.
0.004?
0.01.
Yeah.
They always call it.
That's right. Yeah. I was watching it.
Mm-hmm.
Oh.
0.01 times 0.004. The CL was also diluted. Equal volumes were mixed. What didn't I? What did I say? Oh yeah, okay, yeah, right. And then you multiply them together. 0.0040 molar times 0. No. Yeah, I was reading off the wrong thing. What is the concentration of Ag? 0.10 molar times,
0.002.
and that equals times 10 to the negative 5. So Q is that. KQ, or KSP is this. Is Q bigger or smaller than that? It's bigger. So Q is bigger than the KSP. Therefore, do you get a precipitate? Yeah. Okay, have a seat. Did you do the same thing? Did you get 2 times 10 to the minus 5? Yes. Have a seat, have a seat, have a seat.
I don't know.
I'm going to have you do another one. Not today.
How would you explain how to do it?
That's what I'm doing. That's why I'm saying get to a seat.
I'll be there when it is. And he'll be like, look at these commercial things. And I'll be like, hey, don't say that kind of thing about me. You know, she has feelings too.
Matt, focus. Do I have everybody?
You got me, that's for sure.
Excellent. Portia, Evan, B, focus. Declan, focus. B, stop turning around. Don't bother them. Matt, stop it. Matt, zip it. So this is one of those problems where I really emphasize chemical equations don't represent the truth. They're a tool to figure out what's going on. So number one, the first chemical equation is what allows you to figure out what the products are. And you go, oh, which one of these could be a solid? That's soluble with everything, that's soluble with everything, that's really unlikely. This, we know is low solubility. We don't know for sure if it's going to be a precipitate because we have exact concentrations, but it might be. Then we need to make the net ionic solubility equation. We put the solid on the left and we put out the ions and going from there to here. So we spent like that, I think PLOG or H was like, that was part of the whole unit, was taking that and then getting down to this point. Once we do that, we have to look up the KSP on our solubility table. I didn't give it to you, so that was a whole separate step as well. And being able to get the KSP from that. So there's a lot of individual steps just to sort of lay out the problem. And then a variety of like, what is Q? Well, Q is if this is a calculation of KSP if you know the concentrations at equilibrium. We don't know if this is at equilibrium. So rather than writing KSP, since we don't know if it's KSP, we just write Q. It is technically the same calculation as KSP. It's just a trial, a pretend, a maybe. We want to find out, and we put the values in. The second part is if we add things together, they always get diluted. So if we add equal volumes, you have to divide both of them by 2 because you dilute it. If you add a liter of one and you add a liter of water, you're going to get half the concentration. Someone takes your orange juice and adds another pitcher of pure water, you have half concentrated orange juice. Both your concentrations go in, you calculate that is Q. Go up to KSP, and now compare the numbers. Is 10 to the minus 5 bigger or smaller than 10 to the minus 10? Bigger. So if it's bigger, we have a precipitate. You have proved it with numbers. We will do the next problem on that next day. So you'll have a second shot at it right from the beginning with an example. I'll hold it there. But I'm also going to say, 29. Write down everything as fast as you can. Put everything off your desk. Get out your periodic table, a pencil, and an eraser, and a pepper. I can bring a periodic table to anybody who would like it. I may or may not. But periodic tables you can go up and grab. There's a whole stack of them right there. I'm going to start off just giving everybody their sheet.
back to what must be. Sarah. Portia. Go separate your desks, get everything off of it. Sorry, just remind me of it. Ryan is not here. Sienna. Isabella's not here.
I don't know when every teacher's
I know Leo.
Preston Henry. Your name is correct on there. Oh no, it's like 10 multiple choice and multiple answer or something. Jacqueline? Like one or I have to go look at it right now. You're about to see it. Literally about to see it. The question will be answered in 1 second. Naomi? Oops. Let's have it. We have Evan. Matt Wood, what are you doing? Yeah. Oh, okay. Sure. Fair enough. Second, over here, stop bothering that. I'm probably trying to get away from you. I will turn off the music in 1 second. Okay, I'll turn down the volume a little for those who. Is there anybody who needs it off to concentrate? It's just cut diagrams. Don't panic, people. And you know what would have been worse? When I noticed that if I reprinted it. Can you separate desk in between? Is there anybody who does not have a test?
Can I get a data table? I lost it again.
Newt, you're giving us 10 minutes to do this?